Hello guys, today we are going to see what is pitot tube and its arrangement and the application of pitot tube. A pitot tube is a pressure measurement instrument used to measure fluid flow velocity. The pitot tube was invented by the French engineer Henri Pitot in the early 18th century and was modified to its modern form in the mid 19th century by French scientist Henry Darcy. It is based on the principle that if the velocity of flow at the point becomes zero, the pressure there is increases due to conversion of the kinetic energy into pressure energy. So it is the basic principle of this pitot tube. We can say the working principle of pitot tube. Application of pitot tube. It is used to measure speed of an aircraft. It is used to measure speed of a boat. It is used to measure fluid flow in different industries. It is used where very high accuracy is not required. Now advantage of pitot tube. It is easy and economical to install and the remove. We can easily remove and we can easily reinstall. It is the very simple. It has no moving part, so we not need to the tear and wear and the other friction losses in this. It is a small in size. This is the very small glass tube. Okay, so it is the size is the very small. It is the low in the cost because it is not have any kind of the moving component. Okay, and not have any extra arrangement. Okay, so the cost is very low. It causes very less pressure losses. Okay, we not have the any moving equipments, we not have any obstacle in the pipe. Okay, we not have the length a long length of the pipe, so the pressure losses is very less in this. Limitation or disadvantage of the pitot tube. Mainly we have these two types of the disadvantage in the pitot tube. If any foreign particles flow with the flowing media, then it changes the accuracy of the reading because the diameter of the pitot tube is very small. If any obstacle come with the water flowing and the block to the inlet of the pipe, then we not getting the good accuracy in the measurement. And it is the working principle of this pitot tube is the conversion of the kinetic energy into the pressure energy. So in this case we not have a good accuracy. Okay, and the size is very small, so sometimes we not have get a good reading. Okay, so the accuracy is the less compared to the other modern equipments. Types of pitot tubes. Mainly we have these three types of the pitot tube. The first is a simple pitot tube, just have a glass tube with the angle of 90 degree, the bend with the 90 degree, and the other is the static source. In this we use the two types of mainly the function with the piezometer. Okay, so the static source, we have the another measuring device, the piezometer. Okay, so we have the two component. The first is the pitot tube and the second is piezometer tube. Okay, so such arrangement is known as the static type arrangements, and the other is the pitot / the static tubes. Okay, in this we have the pitot tube, which consists of the two circular concentric tubes, one inside the other, with the some annular space in the between. The one and the two we have the small annular space. The outlet of these tubes are connected to the differential manometer, so we can take the reading. What is the difference in the manometer? We can measure. Okay. Now, derivation of pitot tube. Okay, how to calculate the velocity at the any point. For this, consider a small diameter pitot tube which bend at the right angle. We saw in the figure according to this. Now take the two sections, section 1 and the section 2. Okay, the direction of flow is the positive x direction. Okay, the section 1 is away from the end of the pitot tube. Okay, consider in the left hand side, and the section 2 is at the end of the pitot tube. Now consider that the P1 is pressure intensity at the 1 and the V1 is velocity of the flow at 1. Similarly, the pressure intensity at the section 2 is P2 and the velocity is V2. Now, due to the P1 or at the section 1, the pressure head is P1 by rho g. So, the fluid or the head due to this is denoted by H. Now, applying the Bernoulli's equation between the section 1 and the 2. At the section 1, the pressure head is P1 by rho g plus velocity head is V1 square by 2g plus Z1, and similarly at the section 2 is P2 by rho g plus V2 square 2g plus Z2. Say the equation 1. Now we know that the pipe is the horizontal, the center of the both pipe is the same. Okay, from the bottom or from the top we have the same height from the any datum up to the center of the both pipes. So Z1 is equal to Z2. Now P1 by rho g is the pressure head. We can say the static pressure head. Okay, we have the pressure due to the fluid particles. Okay, so this is say the H. Okay, so in the pitot tube, due to this static pressure, the water is rise up to the height capital H. Now, according to the principle of pitot tube, when the fluid is entered just at the entrance point of the pitot tube, this time the fluid particles not entered directly into the pitot tube because the diameter is very less, and after then it is bent to the 90 degree. Okay, so at this angle, at the 90 degree angle, this angle, the velocity of the moving particles has become 0. Okay, that means they not have any velocity at this angle. Now the total kinetic head is converted into pressure head. So the water is start to rise in the vertical direction due to the conversion of the kinetic energy into pressure energy, and we getting the height is rise up to small h above the capital H. So the small h is rise due to conversion of the kinetic energy into pressure energy. Now the point 2, the entrance of the this pitot tube, it is also known as a stagnation point, and the pressure intensity at this point is known as a stagnation pressure. So the P1 by rho g is say H, and the P2 by rho g is the total pressure head at the point 2 is capital H plus H. We know very well that the pressure is rise due to this condition is the total is equal to this. So we can say this is equal to H plus H, the pressure head at the point 2. Now putting these two values in the equation, this equation H plus V1 square by 2g, and the pressure head at the point 2 is H plus H small h plus capital H plus V2 square by 2g. Now at the stagnation point at the bend of the pitot tube, at the this time the velocity, the V2 is 0. The lower L band in the length is the very small. So the length of the this is the negligible. Okay, so we not have the large difference between the entrance of the pipe and at the bend. It is the very small gap between the entrance and the angle. So it is the negligible. So we can say the point 2 is the nearest to the bend. So at this time the velocity is 0 because it is converted into pressure energy. Now the V1 is this. The velocity V1 is underscore 2g h. Now we know that the coefficient of velocity is ratio of actual velocity to theoretical velocity. So put the value of the theoretical velocity and we can calculate the actual velocity using this relation. The CV is coefficient of velocity. So the CV into V theoretical, so CV into under root 2gh, this is the velocity equation. We can calculate the velocity in the flowing fluid using this relation. Now the another arrangement of the Pitot tube with the piezometer, also known as the static arrangement. So in this the Pitot tube along with a vertical piezometer tube. Okay, so the static pressure which rise in the piezometer is suppose the any height. Okay, suppose the height is small h1. Okay, and at the stagnation point we have the stagnation pressure. So the stagnation pressure is the sum of the static pressure plus the dynamic pressure. Okay, so in this case the datum we can say the above the static pressure. So the water is the rise up to the static pressure in the Pitot tube is equal to the h, and we can calculate the h or we can directly measure the height of the water which rise in the tube, and we can put in the velocity equation to determine the velocity. Now case second, when a Pitot tube and vertical piezometer tube connected with a differential U2 manometer is shown in the figure. Okay, you can see that carefully. In this we have the two tubes. The one is static pressure. To measure the static pressure we have the piezometer tube, and in the right hand side we have Pitot tube. So the both are connected to a manometers. Okay, in the difference of the level of the mercury in the manometer is the x. So the x we can calculate using the relation of the h is equal to x into heavier liquid upon the lighter liquid minus the 1, and then multiply to this difference x. So we can measure the pressure difference, and using to this pressure head to put the value of the head in the velocity equation. The velocity at the any point is v is equal to cv under root 2gh. So the put the value of the h. All the first calculate the value of the h. So the using relation h is equal to x is pressure difference into specific gravity of the liquid which fill in the manometer upon the specific gravity of the liquid which flowing in the pipe minus 1. Okay, so using this relation we can calculate the value of the h and put in the equation v is equal to cv into under root 2gh to determine the value of velocity at any point. Now the another arrangement is Pitot static tube, which consists of two circular concentric tube, okay, one inside the another, with the some annular displacement. That means in the both side of the tubes we have a small space. Okay, so the liquid rise in the tube. The outlet of these two tubes are connected to a differential manometer, where the difference of the pressure head S is the measured by knowing the difference of the level of the manometer liquid, say x, then the h is equal to x in the bracket specific gravity of the heavier liquid upon specific gravity of the lighter liquid minus 1. Okay, then like this, using this relation we can calculate the pressure head h, and putting in the equation we can calculate the velocity. Now we can understand it the better using this the animation video. Okay, so let's go to video.
Consider a piezometer tube. Piezometer tube is just used to calculate the static pressure. By measuring the height to which a column of the liquid rises against gravity. The fluid is static, relative to the moving fluid. Hence, it is normally termed the static pressure. The pressure height would be same, considering the flow is steady and incompressible. But what if we replace it with a Pitot tube? The column height of the water will increases. And this extra height is called the dynamic pressure, caused due to stagnation pressure. When the water particle enters the Pitot tube, its velocity will convert to dynamic pressure. And stagnation pressure is the total sum of static and dynamic pressure. So the stagnation pressure represents the pressure at a point where the fluid is brought to a complete stop. Now let us apply the Bernoulli equation and derive the formula for stagnation pressure. For that, let us write point 1 and point 2. Velocity at point 1 is the velocity of flowing water v, whereas velocity of water at the head of Pitot tube, that is point 2, is 0. The datum height z1 and z2 is 0. Now solving the equation with those value we get. Oh, look! We get the pressure at point 2, that is stagnation pressure, is sum of static and dynamic pressure. Now we can measure the velocity of moving water v, if we know the dynamic pressure. And it can be easily calculated by measuring pressure head. Static pressure is same for both points, whereas stagnation pressure, or the total pressure P2, at Pitot tube is same.
I hope you have understood working of Pitot tube and its all arrangements and how to determine the velocity at any point. So this is the sufficient for today. Thank you so much. Have a nice day.